This first video is just going to be to finish up 6.7 of graphing cosecant, secant, tangent, and cotangent. First thing I did is I went through and I made a pretty chart for the parent functions of cosecant and secant. So please go through and make sure you have all this correctly filled in now that I have them all together on one slide. Then make sure you go through and fill in the parent functions for tangent and cotangent. These are going to look a little bit different, and so we're going to talk about these as well today. Once you're done there, you're going to go in and find the exact values of these different important values to your quadrantals of tangent of x. Use the chart on the last page to find the values here, and then we'll talk about it together. So now that you should have had a chance to fill that in, again, feel free to pause this video as you go. We're going to figure out whether the tangent of 32 pi is 0 or undefined. If you look back at your chart, it is an x-intercept when it is pi times a whole number. So since this is a whole number, this means that my value would be 0. So for both of these first two, you should have put 0. And then for both of these second two, negative 13 pi over 2 and for 27 pi over 2, that is where your asymptotes are at, which means that your function would give you an undefined answer. The next thing I want you to do is fill in cotangent, so do the same exact thing and pause the video. Once you've had a chance to fill in your answers and look at that chart, this is where it's just the exact opposite as tangent. Tangent of a whole number times pi is going to give you an undefined answer. That's where your asymptotes are for those. And then cotangent is going to give you of a fractional number, so 35 pi over 2 and 27 pi over 2 is going to give you an undefined answer. So that's where your asymptotes are at. What we're going to do on here is just go through Desmos then and show you the parent functions of these graphs. So you're going to graph them with me on your paper. I just show you what they look like on here. This is what tangent of x roughly looks like. As you can tell right off the bat, your x-intercepts are at your whole pi values, so 0, pi, and 2 pi. To really show you your asymptotes, I got to type them in. So x equals pi over 2. You can see that the graph is approaching it vertically, both at the top and at the bottom, and this is where your pi over 2 value is, so that is where you get an undefined answer, so your function will not work there. And then at x is 3 pi over 2 is your other asymptote. To show you your important values for cotangent, to give you a graph of your cotangent, again, make sure you've graphed this one in. Cotangent looks like this. It goes the other direction, and it has different intercepts. Your intercepts here, so those important points that you will plot, are at pi over 2 and at 3 pi over 2. And if I look for my asymptotes, I have one at x equals 0 right here on the y-axis. I have one at x equals pi that you can see, and I have one at x equals 2 pi. Again, these are what we will graph, and then we will just sketch the rest of the graph in between. So having these parent functions is going to be extremely important in your notes. Oopsies. What I want you to do then is go ahead and start to graph this. We are going to figure out our shifts and everything exactly the same as before. I want you to write this down and give it a try. The only change that is going to happen at first is that to find your period, you're going to do just pi over 5/3 instead of 2 pi over 5/3. We are still going to graph 2 periods just to keep that consistent with what you've done. But make sure you use pi over your k instead. I'm going to show you the correct answer of these now that you've had a chance to work through it. I've already sketched it on my screen for you. Okay, so my period here, I did pi over 5/3, which gave me 3/5 pi. So I did put 3/5 halfway, just because that's where our one period would go, and then I doubled it to get my 6/5 over here. Halfway here is the 3/10, and then my 9/10 is my other number that I have as well. What I did then is I sketched my graph at first. I knew that these would be my intercepts, and then my asymptotes would be at my second values, because it starts at 0 here and then has an asymptote. Remembering that pattern is going to be important. And then I figured out my shift. My shift is negative pi so your c value, over your k value, so 5/3, which gives you negative 3/5 pi. And if you look at that, so that would take this point right here at 3/5 pi, and it would take it to 0. It would take my 6/5 pi and take it to 3/5. So when you shift that, it really doesn't move anything at all. It matches itself back up perfectly. So this graph, while there is a shift happening, it's an entire period moving over, so it does not do anything to your graph. Okay, over here I have labeled my midline of negative 1/3. You do not need a max and a min anymore because your graph goes to infinity and to negative infinity. Okay. Go ahead and try this one as well then. And then when you have had a chance to try it, you can unpause the video and I will show you the correct answer. So again, like before, I have sketched this and I will just, talk you through how I got all this work. So I started by figuring out that my period was pi over 2. That's the green numbers here. So I did pi over 2. Halfway was pi over 4. My second period then takes me to pi and to 3 pi over 4. When you sketch your cotangent function, I had originally placed my asymptotes on these values, so on those whole numbers, just like cotangent does, and I placed my intercepts, my other green dot went away, on my pi over 4 and my 3 pi over 4. And then I figured out my shift. My shift is pi over 6 to the right, so that is the values that I have added in here. So these asymptotes move pi over 6 to the right of the value that you found. And then my x-intercepts also moved pi over 6 to the right. Since this is cotangent, it starts at the top and works its way down. So there's the sketch of that. I've also labeled my midline right here to be y equals 4. Okay, what we're going to skip ahead and go do is write your equations. Again, like before, this is exactly the same. This has not changed from before. The only minor detail is that now you are dividing by pi instead of by 2 pi. So let me add a slide right here and we can do this one together. So period is 5 pi over 2. So 5 pi over 2 is equal to pi over k. When you solve this, you cross multiply, you're going to get that k equals 2/5. You can use that then for your phase shift. Your phase shift is equal to negative c over k, which is my 2/5. So I'll go ahead and just plug that right on in. Remember, you can flip that, so pi over 3 equals negative 5c over 2. When you cross multiply, c is going to equal negative 2 pi over 15. Then when we plug all of this in, your y equals, you don't know if it's positive or negative cotangent, of 2/5 theta minus 2 pi over 15. And that's done.